Okay, excellent. No new questions. Beautiful. Okay, so I'm going to take this next to just hopefully a very logical extension, just kind of taking it to the next incremental leap forward. And that would be, okay, yeah, just really being able to control like any sort of instance parameter of an object, and then starting to be able to kind of put a little more mathematical control in it. Okay, so here's where we want to go next. I've got a couple examples for you that are really all about that. Really, where we started the class with the whole notion of these parametric towers and how we can go through and start setting parameters, creating family instances, and then setting the parameters of those, and doing it both kind of with sliders as a way of setting the values, but also going through and doing more of like a kind of a mathematical computation, like a sine wave, to go through and indicate some sort of relationship. So let me kind of just start down that path and see how that goes. Okay, because it's really going to be, I think what you're going to find with a lot of what's going on here is we're just going to keep on adding more and more little tools and nuance to what you can do, just to really build up your toolkit of all the things that you're able to do with this. But I tend to just sort of add it very incrementally just to get us self-started and get going. So let me close up this one. And I'm going to open up a different Revit file. Let me go ahead and close this one up too. So again, there's a starting point file for you to use. If you use my starting point file for this example, it'll already have the family loaded in. But you don't have to. You can still load in the family some other ways. It could be a little bit easier. Although I don't have the other little mass kind of loaded out on in the session 2 folder as readily. So probably better to start with this folder if you can, or start with this Revit file if you can. Let's let that finish flashing around for just a second and see if we can do this. What I'm going to do is open a Revit file. I'm going to open this one called Parametric Towers. So when it finishes opening, we'll take a look at it. It's a big old mass element. It's a little bit strange, but we'll see how it works. Let me see if it's even in there right now. I'm going to go to massing and site, just because it may not be showing, and say, maybe it's going to show all the masses. Doesn't look like it's out there yet. Okay. We can go ahead and place one. We can get this twisting rectangular mass if you want to. Just drag it on out there. And I might have to zoom out to see it. Okay, so that's the mass we're kind of looking at. So the idea with this mass is it has some parameters to it. It has a twist, a building top, a building height, a building base, all these different things. And we could go through and just type in a value and apply it that way. And typing in values, it's really the same thing. We can either do that programmatically, or we can do that by typing in manually. Either one sort of works. But we're going to talk about how we do it programmatically, just because that gives you the ability to evaluate a lot of options very, very quickly. So here's what that would look like. So add-ins. Let me open up Dynamo. And you'll see that I've set up a script that actually has some of the logic for this kind of ready to go. And then you go ahead and open. And in session 2, you'll find parametric towers, changing the parameters. Let me just go for the starting point file this time. It's going to look pretty similar in terms of what's going on. Okay, so basically this is all set up as we have some sort of numbers, 0 being used to sort of give us a base point, so an origin point, the XYZ point for locating some family. And then we're going to choose some sort of family, whether it's the twisting rectangular mass or whatever family we want to use here. Let me see if there was a question there. Often that will ping me to the question. Nope. Okay, I'm going to have to find what did I call that thing? It's twisting rectangular mess. Pull that down again. There it is. So what we can do is, based upon this XYZ, create family instance, super. Actually, if we say run right now, what it'll do, it won't make very much of a difference. It'll just basically, actually put a second one in there. That's the one that's programmatically controlled. Right there, so I actually have two instances right now. Let me take that one out. So it's going to confuse us in a minute. That's the one I placed manually. The other one's the one I placed programmatically. And you can actually have things that are programmatically placed and manually placed coexisting in the same file. Okay, so we have that mass kind of placed at 0, 0, 0 right now. So if we want to go through and start changing some of the parameters of that, let's do something that's sort of really easy. For example, building height is something we'll be able to see quite easily. So I can say set family instance parameter. Build myself a node for doing that. There, I can get the instance parameter for that. Scoot that over a little bit. Let's say I spend most of my time just navigating the logic around. Okay, I'm going to take that instance. I'm going to take the building height and say that's the parameter we're going to tweak. Now we are ready to think about the value. Different ways we can do that. I can type in a number if I want to make that happen just as a number. I can put in a slider if I'd like to be able to slide it. I'm going to put a number slider in. That will make it a little bit easier. And what? I'm going to go to 1,000 at the top end. About the smallest I might want is 10. You got to make sure that you have instance parameters. Like 0 wouldn't work. I don't think it would work on this one because you'd have an invalid piece of geometry. But let's see if we can make this work. I'll click on Run Automatically. And let's just try dragging that slider. There we go. Pan it over a little bit so you can sort of see. And so over here, we're getting very direct control over what's going on. And we can control other parameters too. For example, if we wanted to control the building base width, or the building base length, whatever it is. I'll just get another instance. That's another number slider. Actually, we'll use that in just a second. Instance parameter. So again, we'll tie our instance in. And you could have different instances. Kind of almost a Natasha's question. You could have different sort of sliders operating on different instances of objects. I guess you can combine things together in different ways. Parameter, and I'll put a value in here. Okay, so now I got a couple different sliders. Okay, and I can control either one of those. Okay, so the idea of being able to kind of control the parameters of different types of families, really, really very useful. Then we kind of just control a slightly different one here. This little twisty tower, he's kind of interesting unto its own right. If, for example, I wanted to choose something a little bit different, for example, the rectangular tower or triangular tower is even a little more interesting. Do that instead. You notice when I do that, some things became invalid. And what's become invalid is some of these different instance parameters are no longer valid because for the twisting tower, there's different instance parameters available. So they're showing up in red right now. So let me pop back out here and let's take a look at what parameters are available for this tower instead. See if I can choose that guy. So what do I have in here? I have things like, mid radius, top radius or top height. So if, for example, I change this to instead like mid radius, you'll see that now it's a little funny looking because I have something that has a very broad radius in the center right now. But I can very quickly start experimenting with different forms. What was that other one? Was it top height? Let's try that one. But any of the parameters. It's basically all you're doing is changing the parameter values within Revit. So hopefully you're getting a sense that this ability to kind of pull sliders around and do things like this could really make testing different forms, testing different geometries relatively quick. And that's really the idea behind all this. It's really just by being able to programmatically generate all these different forms very, very quickly, ultimately then we get to evaluate them. Okay, so Pablo says, I can only set family type parameter, not set instrument. Now when I connect the lines, it gives me an error. Okay, so it really, how do I add all the parameters? By adding all strings. Yes, so for Natasha, for every different parameter you want to control, we just have to add different strings. And then really each of these nodes will control a different one. But for Pablo, the type parameters would only work, well, let's talk about this. Instance parameters connect to an instance. Okay, so create family instance, so FI goes to FI there. If you want to do a type parameter, let me try that one over here. Set family, so there's type and instance over here. Type is over there, but for type parameters, the important thing there is we basically have to go from a family type to the type parameter. So it's a slightly different linkage. So type parameters operate on entire types, whereas instance parameters operate on different instances. So Pablo, are you able to find the instance parameter, like just as a node, or you can't find the instance version though? Do you have a create family instance and then link to that? Or is it just that you can't find the node, or is it that you don't find an instance to link it to? You can't find the node. Oh, well, do you have something in your little diagram that says create family instance? If not, go ahead and do that. Let's try create family instance and see if you have that one. Okay, and then do you have a node that says set family instance parameter? Or is that the one we just can't find in the library? Raj, can you go over and kind of take a look and see if we can help them find it? It's really under the Revit branch, then families, and should be family instance. If you just type in the library thing, if you just type instance, see if you can find it that way. If not, there may be something weird going on in terms of just the different nodes that are loaded into your system. So if you just type that, I'm just going to wait for you guys for a second. Nope. Yeah, to see if anything does turn up. So Pablo, if you type in instance, kind of like it is on my screen right now, do you get this list over here that starts with create family instance and goes all the way down to set family instance parameter? Everything except the set. Okay, not sure what's going on. That's definitely something strange that we just got to do some debugging, because the fact that it doesn't have that one is a little, yeah, it's odd. Somehow, all these things are stored out in a library that comes from, just our installation. For some reason it's missing on yours. We just got to figure out why that is. So I think that's just more about the installation than anything you're doing right now. Okay, so I apologize for that. I think because it's not showing up in your library, there's a couple of people with the same problem. Interesting. Okay, that has something to do with the installation, and I'm not sure what it is right offhand, but let's see if we can debug it. Okay, but for right now, let's just kind of like, Raj, if you can kind of sort of make note of people who have those, and then when I'm back on campus, we just got to like start trying to debug those machines in terms of really why that is, that if you type instance, it's quite unusual, because it's really, that should all just be loaded up automatically. I'm wondering if it's anything about newer versions. Yeah. Actually, one thing to check. I'm looking for the about. Yeah, we just got to do some debugging about why that is. Yeah, is and isn't on some of those. Okay, so thanks. Okay, thanks, Patrice. Thank you. So let's go ahead and, yeah, we'll see if we can debug that for some people. Oh, excellent. Thank you, thank you. Okay, something just happened where, Dynamo just didn't get installed properly. Let's see if we can do that again. Okay, and then, for versions, I think it's the 0.63 version that we're working with. So let's make sure we're all working on the same version too. Okay, so with that notion of basically starting to create these different, control these different instance parameters and stuff like that, let me take you just one step further today, just to kind of give you a sense of like how this could be useful. And to do that, what I'm going to do is open up just a slightly different script file. Okay, I'm going to keep the issue of like, my basic little controllable tower here, but we're going to change it up a little bit in terms of just the scripting. What I want to do is actually look at the whole notion of, can we go a little bit further to say that we want to control the tower to actually have the heights determined as more of a sine wave, so something where a little bit of math is determining those heights as opposed to determining them manually. Okay, so what we're going to do is, it's in many ways the same sort of thing. We're going to create some Revit families. We're going to set a family instance parameter to control the height of that thing. But then we're going to go through and just compute some sine wave values for the heights, as opposed to just putting it in with a slider or manually putting it in there. Okay, and sine waves are kind of cool things in that we can compute the value based on some x value, get the sine of that x to kind of compute, some sort of undulating curve values. We could also start to adjust the sine wave in terms of, since sine waves go from positive to negative values, we want to be able to kind of control a baseline, so some minimum height so that you don't have a negative building height, and also like an amplitude, how big do you want the effect of the sine wave to be? Okay, so we got, both those things in there. So most of what we're going to do is just play around with the control of the sine wave and how that actually affects, this building height. So let's go ahead and take a look at an example that would implement that, and that's where we'll finish up for today. So we have out there in the list of examples for you, what is it? It's the parametric tower's sine curve. And let's talk about that. And open up the starting point. The idea is at some level, we're just going to move this around so you can sort of see. It's pretty similar to what we've been talking about so far. We have an origin point. Actually, in this case, what I have is a series of different points because I want to put a couple of different towers. What I'm doing is I'm creating 5 different origin points that are all 200 feet away from each other, 200 units away from each other. So I'm using those to really kind of create this notion of the origin of the tower. Okay, so it basically has a series of different points, and if I looked at what this is going to go through and create, let's write it automatically. That's going to create these different values here, yeah, of the sequences of the x points, and hopefully it's going to create a whole series of points for us. Okay, and then ultimately, what we're going to do is take this twisting rectangular tower and create a family instance, okay, where we still have the notion of the height, okay, and the width. Okay, so I have a couple sliders on here. Let me just kind of take you through that and kind of show you what that does so far. I'm going to get rid of my big triangular tower just so it's not confusing things. So basically at this point, I have these 5 different instances of the tower over here. It's that same little parametric model. And in terms of those, we can kind of control either the number of them or the distance they're apart. For example, right now there's 5 of them. And again, I'll put a slider on here if I want to, or just kind of manually enter the values. So now there's 4, now there's 3. And I can control the spacing. They're 100 feet apart from each other. They're 150 feet apart from each other. Whatever I want there. Maybe I'll make like 8 of them. It'll be a little bit easier to see a wave. Okay, so I'm creating these different towers, and then within these different towers, there's the whole notion of just the parameters that control them. So, for example, I'm controlling 2 different parameters right now. I have the building base width, and as I slide that one out, you'll see they're kind of getting fat or skinny. More pyramid-like. And I can also go through and control the height. So for example, for the height, let me just put a string in there or a number in there right now. And I'll just make them all 500 for right now. It's interesting. Who doesn't like that? Think about this like that just a second. How do you think that would look? Okay, looking a little bit better. So I got these different towers, they're all kind of moving up, and they're looking pretty good. Here's the deal though. As I look at these different towers, they're all uniformly heighted right now. They all have that same height. If I'd like to go through and do something a little more interesting, actually have something programmatically change at the top, I could use attractors. For example, I could do something about the distance to the sun. Well, that wouldn't change very much. Or distance to some other object, and kind of change the heights that way. If I want to do something like just a simple mathematical relationship, have a little undulation in the heights, I can do something like that too. So here's how we can go through and construct something like a sine wave. What we need to do a sine wave is basically we just have to feed in some value that it's going to compute the sine of. And what I'm going to do is actually just take those x values, because the x values are actually, they're the things that's changing. The y and z values on these are all staying the same, but I'm just going to grab that sequence of x values and feed them in to the sine function. So take that and take them down to the sine function. Okay, so, oops, come on, you. There we go. So now we have a whole series which is the sine of all those x values. Okay, now the sine of all the x values, as you look at it, and all those values, let me see if I can scroll on down. Actually, for all these are all still positive. Okay, which is probably a pretty good thing. Let's go ahead, and we could just take the sine of all those values and connect them in as the heights. Okay. But, well, in this case, it's even going to complain because they're just too short. Since the sine values typically just vary from like 0 to 1, or negative to a positive 1, that isn't very interesting. So what I would really like to do is actually take those sine values and do a little multiplication together to really put an amplitude on there just to make it a little bit bigger. So for example, as opposed to connecting it that way, let me take that out. What I'd like to do is actually just multiply some of these values together. So if I want to go through and have some amplification, I can use the multiply function. And what I can do is take all those sine values and multiply them by some amplitude factor. Okay, and that's going to give me a much higher range. Okay, so now it's going to go from 70, 100, it's something like that. It's going to be much more, and that'll be appropriate. So now I could take those that are scaled up. Still not quite liking it. Something's going negative just where I can't see it off the screen, and that's okay because that's what it's complaining about in terms of negative. What I would like to do is, though, to really give us control of the sine function, not only sort of have it sort of be a broad wave, something that goes from 0 to 100. Okay. What I'd like it to do is actually add on to a base value. That way you're moving the baseline of the sine wave up as well as controlling the amplitude. So what I've done is I set up this other sort of thing here, which is really the notion of just a slider, okay, for controlling the baseline height. And then what we'll do is have the wave vary from that baseline height. So how we can do that is we can add. Where might I go? So I'm going to take the baseline. I'm going to take the amplified sine values, and I'm going to use that as really the input for the heights. Let's take a look. So now we start to see over here, we have something that looks a little bit more like a sine wave in terms of what's going on. So I can control that in a lot of different ways. If I control the baseline slider, you see that it's going to sort of move up higher off the ground in general. If I'd like to see even a higher amplification, zoom back in there. We can say this amplitude, maybe as opposed to just being a single value, we'll do a little multiplying here. Oops, not that. Hang on. There's that one. There's that extra add. I knew it popped in there somewhere, I just didn't see it. Let me do a slider in there. So I can make this like my amplitude slider. Okay, and let's say that can go anywhere from 0 to, I don't know, let's say 200. The important thing is my amplitude, my baseline has to be higher so that I never, that the amplitude will not overcome it because I can't get a negative height. You have to watch out for that. But let's say that we'll multiply, as opposed to a single amplitude, this slider value in there. And let's see what that looks like. So we're hanging around over here. We got those towers. That's at 200 or something like that. Let's try bringing it up even higher. So everything from a more extreme curve, okay, or watch this, if you actually go through and make it very low amplitude as a wave, you're essentially creating a flat surface, or just somewhere in between. depending upon the strength of the wave that you want to see there. And again, the only thing we have to watch out for is I can make that an extremely strong wave. But what I'm ultimately watching out for is that the baseline has to be high enough that the bottom of the wave never dips down and goes below zero. Okay, let me pause there for a second, because that's really the point of this, is that really, okay, great, we got control over all these parametric values, that's super. Now we can actually start applying not only just kind of direct control of those sliders, but we can actually start using mathematical relationships to start building in very interesting things. So this is already starting to get a little bit interesting architecturally in terms of what we can do to kind of create these undulating surfaces that kind of catch the wave and do things like that. But we're going to go, as we go further and further in this, is realize that we can start adding more and more programmatic control to have these determined based on different calculations, things about the environment, so that these values that are being tested are not just sort of arbitrary, me pulling sliders around, but actually kind of dictated by more kind of driving forces that we're trying to optimize. So let me pause there for a second. Any questions? All good. Excellent. Okay. Very fine then. Okay. Let me do this then to finish up for today, just to give you a little teaser of where we're going next time. Let me open one last project. And again, this is one we're going to work on together next time, so don't worry about following along. We'll just give you a sense of where this is all going. And that is I'm going to bring this up as an example for you. This is actually inspired by something that came up in 120B, and actually it came out of CJ's project. So CJ, if you're there somewhere or watching online, this example is inspired by you. The idea is we have a whole bunch of windows here, and all sitting there in a row looking perfectly ordinary in terms of just all being the same height and all having the same sill height and things like that. And what we want to start experimenting with is, can you actually use this sort of scripting control to kind of create sort of more artistic effects? So what we'll learn to build next time is actually something that looks like this. Let me open it up in terms of the script. Back out to here. This is a script which involves nodes that are really just trying to take the whole notion of sine wave along with a frequency, an amplitude, and a base height, okay, and really apply it to ultimately control the height of the windows. That's what it's all about. So a lot of math and different sliders that really ultimately let us set a family instance parameter, okay, which is just the sill height of the windows. So let's take a look at that in force. Okay, so let me run this automatically. You'll see that by default, everything's looking about the same. I can go through and start messing around with these parameters for the base height of the windows. Okay, and they're all moving in a perfectly straight line so far. Shrink that up so you can see it a little better. But we can, in addition to sort of just moving the base height of the windows up and down, start using that sine wave to introduce things. Right now, the sine wave has an amplitude of 0, so it's flat. But I can go ahead and start really having programmatically determined, very artistically placed windows. Okay. Another attribute that we'll learn to add next time is sort of notion of the frequency of the wave. Let me kind of show you what the impact of that is, because that's, again, when you're working with these mathematical formulas, there's this whole question of like, oh, how your building elements stack up to the natural frequency of the curve that you're in there. So you can sort of see everything from, if I make the frequency very, very small, you start getting a very smooth kind of curve. As I start pulling out to a lesser frequency, you can still see, or a broader frequency, you can still see that the curve, but it's getting a little diffuse in terms of understanding what's going on. All the way down to, if I start getting to a very broad frequency, you may have a hard time as recognizing that as having come out of a sine curve. But it is. It's just that we're sampling the values around that curve, very sporadically. So you don't recognize it as being a curve, but it kind of creates an interesting, what appears to be a random effect, but it's actually very, very programmatic. Okay. So let us just finish up there for today. Let us adjourn with the old idea that we're heading down that path with just continuing to sort of use these functions and the programmatic control to start manipulating and controlling what's happening in the geometry of the Revit model. And we'll just continue that, just kind of continuing to add facility and more control. So we move beyond just kind of doing this funny mathematical things, but trying to drive it so we're starting to try to optimize different conditions. So trying to pull numeric values out of the Revit model that we could then use to help determine behaviors. Okay? So let us adjourn for the day. We'll hang around for a little bit here as anyone has any questions, but thank you all for kind of hanging online and doing it this way. I'll get the recording up just as soon as we can.